So this magnificent place is a giant wetland. This is Great Lakes twig rush wet prairie. As far as ecosystems go, this is the most rare that we have. This is under classification as a G1, globally 1, critically imperiled. That is 5 or less occurrences left globally. It's structurally much like the Everglades. Is a good comparison that a lot of people are familiar with. And again, we have those edaphic soil processes in place. What makes wet prairie is that it gets super wet and then it gets super dry. It's a very fire-driven system. Sometimes we put too much fire in as a management tool, but it is a fire-driven system, much like what you see down in Florida. To talk about the soils, and these are some of the most important. All right, as you're looking at it, you've got this muck soil. This is called a muck aquitard. It holds the water on the surface, and you also have an unconfined aquifer below. This is the same sand that we see up in the dunes. If you've seen that sand, it's orange. It's got iron in it, and up there it's rusted, so it's oxidized. And in here, because there's no way for oxygen to exchange down into here, it becomes oxygen deprived and becomes reduced. When you're thinking about how much, and remember, soils build themselves up, so this is almost purely organic matter up here. There's very little parent left in it. The water stops decomposition, and that reinforces the wetland. Okay, so originally it was a wet sand plain like what you see down here, and this stuff has built its way up on top of it and helps to hold this wetland in place. Once the water goes away, because there's water filling all this up, once this begins to dry up, it'll dry out on the surface, and that's really what makes that wet prairie. You have the brutally wet, like you see right now in the spring, to the brutally dry, and there's a lot of variability. The biggest flood that I've seen out here was in October and November of one year, and if you're thinking about just the 50 or so acres that are around me of really prime wet prairie, that was 16 million gallons of water that's stored in this wet prairie, not flooding somewhere else during those catastrophic events. It's also it has filtering capacity. I don't want to route nasty agricultural water in here to fix it, but we can employ these kinds of designs around our fields and filter some of the excess nutrients off from that. What makes it so rare? Again, it's the soils, but then also the differences in hydrology. This used to be 7 miles by 1 mile of treeless wet prairie. We've put ditches in, drainage improvements, and so forth, and that's allowed more of these kind of scrubby shrub lands to come into place. This one's been a little overfired in trying to manage out glossy buckthorn and invasive shrub. It's starting to come back though. What I want to see are big, thick shrublands with pockets of these little prairies in between them. And there are examples of that in the oak openings. The aggressive management does not preclude having that kind of environment. And these are some of the native shrubs that we have: red osier, dogwoods. The pin oaks are pretty much the only tree that can tolerate this wet and dry. So, yeah, G1, critically imperiled. That's 5 or less left in the world. Everyone's like, where are the others? They're up in Michigan, Ontario. So this is a very important thing. You can go all over the world and see rare stuff. You can see rare stuff right down the street. A lot of the plants that are in here, this isn't the big mother lode of species that are rare to Ohio. they're not common by any means. Their combination, of course, is extremely rare. I think what's most important in these wet prairies are the vertebrate species, which includes, this is primo spotted turtle habitat. Blandings turtles will also use this type of habitat. We have salamanders and snakes, and of course the frogs. These are gray tree frogs that you hear calling in the background. Birds, migratory birds are using this. We're starting, now that we're managing this back into more of this state, we're starting to see more bitterns and things like that popping up out here. Wilson snipe, sora have been nesting here for a while. It'd be nice to get like least bitterns or yellow rails. There was one black rail seen here many years ago. So that's a big component that we won't be able to address with video because animals are hard to move. But it doesn't underscore the importance of this environment. So yeah, when you're thinking about all this soil, I don't think I said this, so I'm going to throw this in again, and we'll edit it out if it didn't, or did. This amount of organic matter that you see here is basically, well, you know, prairies are a forest flipped upside down. A wet prairie is 5 to 7 times more organic matter than a woodland. Right? So where these soils occur, it's super important to protect those soils and make sure that they're functioning in their best possible way. So let's go, we're going to move around the prairie. I'll show you some more trees, less trees, more frogs, all kinds of stuff. We got a good one tonight. Okay, so we're getting a little more into the trees over here, and this is what is important to understand about the system as a whole. It's not one or the other. Okay, it's this gradient of going into trees and then coming back out of trees. The oak openings is important because you've got these wetlands, a G1, 5 or less occurrence wetlands, and in some places within feet, and I'm not kidding, I've got a photo of a feet distance between a wetland and a blue lupin blooming on a dune next to that wetland. So you've gone from G1 wetland to G2, 20 or less occurrences, xeric, almost desert type environments in very close place. I don't know of anywhere else where you could do that. Perhaps in Florida, southern Alabama, southern Georgia, but that's really the essence of this oak openings, is that in very little topography you go back and forth very quickly, and it's driven by the soils, those edaphic processes. Right? The geology, the hydrology set the tone for how organic matter interacts with the landscape, how it's stored, how it's released. A fire releases lots of organic matter, right? We send carbon off, but remember, we've got those thick muck soils under here that are storing far more organic matter than you see in these trees here. There was a towhee screaming his head off out here a few minutes ago. Now he decided to stop. But you're starting to get into more of the savanna continuum, right? That's 16 to 32 trees per hectare, 2.5 acres. On the wet prairie, where we were out in twig rush wet prairie. And there'll be inclusions of that in here, and there'll be inclusions of this over there. All right, by inclusion, I mean there's a little patch that looks just like this out there. It goes back and forth. It's so fluid. All right, and I can't tell you when you're in or out of one thing. We got to just kind of make best guesses. And I'm going to show you some stuff with the genetics, and we're in a big hybrid swarm here. It's a young landscape. A lot of this will erode. You're looking at essentially a river of grass right here. That's an outside bend. You're on an inside bend, and it goes off over that way, and then it comes back. All right, it has the same geomorphology as a river. It's just really wide and flat, and that's what the oak openings is. It's an ecotone. It's that interchange zone between two dominant communities, spread super wide with these little patches going back and forth all the way through, where you say, well, that's a swamp forest, or that's a wet prairie, or, well, this is kind of severe. Yeah. Why do we need to classify things? Because we're ecologists, and we're humans, and that's part of our nature. But I just love this place, man. I grew up here, by the way. I had no idea until I was 26 years old. So don't feel like you're behind. What did we just try to do?
Find a salamander, but we couldn't.
We tried to find a salamander, but we couldn't. Why did we want to find a salamander?
To be in Daddy's video.
To be in Daddy's video. Why else would we want to find a salamander? Huh?
You know, I don't.
Oh, you know everything, though, I thought. You knew all the things I don't know.
Well, I don't know part of it.
Okay. So the reason we wanted to find a salamander is because a lot of people think these salamanders aren't important because they're hybrids. And let me explain a little about that. Lucas County does not care what your species concept is. There are lots of organisms that go across boundaries of what we accept or like or prefer in our little boxes that we put things into. And the salamanders are one of them. But I think the hybrids are actually more interesting than a good diploid two-parent organism because they're all females. They're called unisexual ambystoma. They're all female, and they can pick up sperm packets from all sorts of other species. Okay, so the two predominant ones that we have are the smallmouth salamander, which is to the south, and the blue spotted salamander, which is to the north. And most any of those ambystoma, the mole salamanders that you see around here, are a combination. But in these wet prairies, we'll get good diploid parents.
Oh yeah, and we won't find one.
And we won't find one. Why won't we find one today? There's too much water. There's too much water. This is the wrong time to find them. So we tried real hard because we wanted to have one in hand when we were talking about this, but what they do, they're called polyploid. And they will pick up other species, sperm packets, the females will, and they'll inseminate those packets. Those eggs will develop. They're not supercharged. When you find good diploid egg packets, they get this glowy green algae that helps them along. But they require stable water. And we need to have water in these wet prairies until around about July for them to go through full metamorphosis. That's the blue spotted, which is the rare one here. In Michigan, they'll get all excited about smallmouth salamanders, good diploid smallmouth salamanders, because there's not that many floodplain forests that are
Nope.
that resemble across Ohio and south and west through Indiana to Illinois and so forth. So yeah, I think that's more interesting. It's not just the salamanders that do it. It's the plants, it's the birds, it's the fish. Everybody mixes it up here, and it's because we've got this very young landscape, and the genetics are coming back together, and we get some amount of introgression. And for some reason, we've decided that's a less noble state of being for an organism, but I find the adaptation to be fascinating. So unfortunately, we don't have a smiley little blue guy here for you. But
I found a cool brick.
you found a cool brick?
Instead.
Yeah, instead. You want to show him your brick? Yeah, look at that, a little chip off of some wood. All kinds of fracture lines, huh? So this is a restoration area. We've cut a huge understory of buckthorn out of here, glossy buckthorn. It's the big green wall that you see back there. That line there is the outside of our management unit. We're starting to get some of the sedges, grasses that would be out in the wet prairie in here, although a little more shaded. Right? We've got some filtered light in here. This thing's going to be sick. This is year 2. You hear how many tree frogs have come in here. Wood frogs came in. We've seen snapping turtles in here. We're hoping to see other turtle species show up as well, glandings in particular. It's pretty deep. There are areas that are up over my knee that go over my boot, largely from blowdowns that have torn out. We had a monstrous set of trees go over already, just from opening this up. And there are 2 things that were in here. Where I'm standing used to be almost complete light extinction. Alright, on a cloudy day like today, it'd just be dark in here. You had an understory of buckthorn, and then you had an overstory of red maples. And remember what that core looked like. You've got that muck on top of the sand. Same thing in here. The sand's running under all this. And the sand's not shallow. That's a big misconception people have about this. The sand here is about 4 meters deep, 8 to 9 feet. There's a lot of sand, but it's all got to drain across the sand to get out of here, and so this will eventually go dry. But this particular environment is much more like the rest of Ohio, okay, not like the wet prairie out there. Now, we could cut down all the trees and burn it a lot and do some things and turn it into a wet prairie. But again, we're trying to get that whole continuum of conditions back into place. And so that's why we're doing the management we're doing. We've done this with UT students. A lot of students taking this course have participated. This is mainly for the people who are coming from the outside after the class is over. We've cleared 25 acres out here with hand tools in 6-7 years. It's really incredible. Once you start, it just goes. So kind of fun. It's coming back to life. It'd be interesting to film from this very spot in 4 or 5 years. Maybe we'll get a good fire in here and it'll stimulate some more of the seed bank. That's another important concept. There's this whole rich seed bank from another time living under all this muck soil. We burn down the stuff that the buckthorns put in place, and it does put some more carbon into the soil, but it's a lower it goes back into the atmosphere faster. There's papers that show this. So it's not a beneficial carbon sink, so to speak. And we do gas off a lot in the short term. But when we get this water down here, it starts doing an important thing. So we're talking about our nutrient cycles and so forth. This black water, if it gets hot in the summer, it is pumping a ton of nitrogen back out of the system. As you're walking around, you smell swamp gas, and that's because there's no oxygen. If it gets hot, it doesn't store the oxygen, and it's really essentially filtering everything on the highlands around it. Right? This is the ecosystem's liver. Same with the wet prairie, although this spread super wide, and it was an ecotone of this spread super wide. Okay, if you're trying to visualize how that ecotone is spread out across the landscape. But these places are super important. So we start in the wettest areas to begin getting that water and organic matter and nitrogen to flow down into these wetlands and allow the ecosystem to function as it once did. It's like it's been eating cheeseburgers for every meal for forever, right? And again, that's tied back to our use of fossil fuels, farming practices. That nitrogen's got to come from somewhere, and it's probably from our cheeseburgers, a lot of it. So hopefully that kind of gives you an idea of what we're trying to do, and working to enhance these ecosystems so that we can get this that silent spring gone. 4 years ago, this was totally quiet back here. Even 3 years ago, that was probably the first year they came in. Last year it got loud, and it just keeps getting louder. It'll come back. It will come back. And that's an important key point. I'm gonna throw in a swear here. Mother Nature's a badass lady, and she is sick of our shit. And you're watching it. She bats last, and she bats clean up. Mama ain't happy, ain't nobody happy. So we better get on the stick and start doing a thing about it. Ever seen water flow uphill? There go all the fish. Probably carp. I've seen 38-inch northern pike over that way. So there's so much head pressure coming from upland. So this is a low spot in between a couple features. When you think about the oak openings, it's a recurved spit like this. The barrens are up on top, Irwin Prairie's down in here, and then there's another highland as you go westward, and so all this water pushes its way in here. It's also backing up the water that's coming down this way. But yeah, fortunately we've got enough water on the landscape that this tannic water is what's up here. Sometimes in the spring, you get a big flood or whatever, and all that agricultural water, that muddy water, comes right up on the prairie. In fact, it kind of shocked us one time. We were cutting trails, and it was like making hay, and I was like, oh, we could have organic hay. Except it wouldn't be organic because it's got too much chemical crap and extra nutrients coming from upland. These are ways to disrupt these things. You know, I've got a 45-mile-an-hour road running through a G1 wetland. Let's take this road out. It doesn't need to be here. Lots of threats. It's death by 1,000 cuts. You can't blame it on anyone. But all of them together, they make a difference.